MIT astronomers discover the oldest oscillating quasar in the universe.
Astronomers from the Massachusetts Institute of Technology, MIT, and other institutions have identified an oscillating, blinking, quasar in the early universe, when the cosmos was only 850 million years old.
This discovery, announced in June 2026, represents the oldest oscillating quasar ever observed and reveals that an extremely voracious supermassive black hole was already surprisingly mature at that distant time. Quasars are the most luminous and energetic objects in the universe. They arise when a supermassive black hole, located at the center of a galaxy, attracts large amounts of gas and dust. This material forms an accretion disk, a kind of hot vortex around the black hole that releases enormous amounts of energy, shining brighter than all the light from the stars in the surrounding galaxy. Until now, scientists had found many quasars in the early universe, but only as bright points of light. For the first time, it was possible to observe the blinking of one of them. This oscillation occurs due to variations in the amount of material falling into the black hole, and it allows us to study the shape and structure of the accretion disk. The researchers, led by Anna Christina Eilers and Jean Leung of the MIT Kavli Institute, analyzed infrared data collected by NASA's NEOWISE space telescope over 14 years. They detected a quasar that shone with the intensity of 12 trillion suns and oscillated about 20% in brightness, irregularly, like the flame of a candle. Surprisingly, the accretion disk of this ancient quasar was thin and flattened, similar to that of more recent quasars closer to us. Astronomers expected to find more bloated and chaotic disks in black holes still forming. This mature structure increases the mystery of how supermassive black holes could grow so rapidly soon after the Big Bang.
It seems that the fastest and most turbulent growth phases happen very early, before we see these objects as bright quasars, explained Anna Christina Eilers. Jean Leung added, something must have occurred even earlier for these systems to already appear so mature. This observation shows that the feeding processes of black holes and the structure of their disks already existed in the early universe, even under cosmic conditions very different from today's. Scientists now plan to observe even further back in time to understand the initial stages of formation of these gravitational giants. The research, published in the journal Nature Astronomy, was partly supported by NASA and helps to better understand how black holes have influenced the evolution of galaxies since the earliest times of the universe.